Hi everyone! Okay, so today we are doing perimeter and areas of similar figures. It is 10.4, and hopefully some of this stuff sounds familiar after the activity that you guys loved in class today. All right, so a couple reminders. All right, hold on. Remember, the scale factor is known as K, right? And when you're writing it, of two similar figures, you can write it a couple ways. A to B with a little colon in the middle, A to B as a fraction, and A to B as words. And the ratio of perimeters is simply just A over B, whatever that scale factor is. They're going to be the same. All right, and the ratio of areas is whatever that scale factor is squared, both the top and the bottom squared. Okay, so once you know your scale factor, you know that's going to be the same for perimeters. In order for whatever you get for area, you're going to need to square it. Okay, let's look at some examples. Okay, it says find the scale factor. That's the first thing that we want to do. So I'm going to go ahead and I'm going to put 6 over 9. All right, the 6 over 9. But I do need to simplify it. They both are divisible by 3. So I'm going to do 6 divided by 3 and get 2, and 9 divided by 3 and get 3. This is it simplified. So there's my scale factor. Right, this is the same ratio for the perimeter. All right, same ratio for the perimeter. If I want to find it for the area, then I need to square it. So 2 squared and 3 squared. Your ratio for area would be 4 to 9. Okay, your scale factor squared. Let's try it again. The area of a smaller pentagon is 27.5 centimeters squared. Find the area of the larger pentagon. Sorry, guys. I have the worst sneezes lately. Allergies, I guess. Okay, so let's look at some of our pentagons. Here is our pentagon, and it's 4 over 10. It's 4 to 10. So I'm going to write it 4 over 10. As a scale factor, and then I'm going to reduce it. That's going to be 2 over 5. Well, now, since I'm dealing with area, I'm going to square it. I'm going to square 2, and I'm going to square 5, and get 4 over 25. Okay, and it wants me to find the area of the larger pentagon. So what I'm going to do is I'm going to do 4 over 25 equals 27.5 over x. Remember, it gave me the area of the smaller pentagon. That means I'm going to need to take the measurement for my smaller figure and keep it on top. They both must line up. I'm going to cross multiply, and I'm going to get 4x equals 687.5, 25 times 27, and divide both sides by 4. X will then be 171.88. Or my area for the larger figure will be 171.88. All right, let's move to the next page. And it says, find the perimeter ratio of the larger to smaller figure. But it's the larger to the smaller, and it's perimeter. And here we're given area. Okay, so we're going to have to take 98 and put it over 50, from larger to smaller. So 98 is going to go on top, 50 is going to go on the bottom. I'm going to simplify this. They're both divisible by 2. All right, and that's going to be 49 over 25. Don't forget this is the area, and we square area. So in order to get the perimeter, we have to take the square root. Well, the square root of 49 is 7, and the square root of 25 is 5. The square root of 49 is 7, and the square root of 25 is 5. So the perimeter ratio is 7 to 5. All right, in order for your full stamp, go ahead and answer this question. Two areas of smaller rectangles. The area of two smaller rectangles is 1,875 feet squared and 1,300 135 feet squared. What is the ratio of their perimeters? Go ahead and answer that question, and I'll see you guys tomorrow. Have a good one.